Now let's take a look how to complete the square when we have a leading coefficient. I added this note to the right to show that we're going to be using a slightly different method than a lot of other examples or tutorials we use. They'll use division to get rid of the leading coefficient. We're not going to do that, specifically because in future lessons we can't divide out the coefficient. We need to keep the coefficient there, and that skill is much more important than being able to solve a quadratic by completing the square. So we're going to keep the coefficient by using factoring and add division into a later step in the process of solving. So we're going to start out the same way that we do with any completing the square, which is moving our constant to the other side, giving us room to complete the square. We'll put in our boxes, and that's where we'll put our b over 2 squared. But before we actually complete the square, we're going to factor the leading coefficient out. Regardless of what it is, we're going to factor it out. That's going to change what the equation is, or the expression that I'm trying to complete the square on. I'm now trying to complete the square on this part alone, not on the entire polynomial with the leading coefficient. Go ahead and we'll use our b over 2 formula, b over 2 squared. Our b value is now 4. It's not 8 anymore because we factored out that 2. So the value that goes in the box is 4. But I want you to keep in mind that on the left-hand side of this equation, we're not actually adding 4. If we consider this expression as a whole, that 2 is being distributed to all parts of this parenthesed expression. So we're actually adding 2 times 4 to the left side of the equation. That means on the right side of the equation, we also need to add in 2 times 4, not just 4, in order to keep it balanced. And so this is the extra step that we're going to have to remember. When we factor out the 2, we're also going to need to multiply by 2 on the right-hand side. From here, the process of completing the square remains the same. We'll bring down the leading coefficient, we'll factor our trinomial, and we'll simplify the right side of our equation. Now we just complete the square. This step will be a little bit different because now this is when we're going to do our division to get rid of the leading coefficient. We have 5 halves. We apply our square root property. Don't forget the plus minus. We have square root of 5 over square root of 2. We will need to rationalize this. Square root of 10 over 2. And then we can go ahead and bring our constant over, 2 plus or minus the square root of 10 over 2. So we only really added in one step, and the division ends up being done later while we're completing the square with the leading coefficient. Let's do a couple more examples. We move our constant. We factor out the leading coefficient. Because we factored out a coefficient, we need to remember to multiply on the right-hand side. Now our b over 2 squared. Oh, I forgot to actually factor out the 3. It's a common mistake. Don't forget to double check that. 9 becomes a 3 when we factor out a 3. Our b value is now 3. 3 divided by 2 doesn't simplify, so we square it and we get 9/4. Now that we have it squared, we can go ahead and factor and simplify. The square root of 9/4 takes us back to 3 halves. So we have 3x minus 3 halves squared. And then on the right side of the equation, get negative 5/4. Now completing the square is done, we can go ahead and solve. Divide both sides by 3. Square root both sides. In order to rationalize, we can actually multiply by the square root of 3. That gives us a denominator of 36. So when we simplify and also writing in I notation, we end up with plus and minus square root of 5 over 6i. And then we just bring our constant over by adding 3/2 plus or minus square root of 5 over 6i. Move our constant. Factor out our leading coefficient. Now, since 5 can't factor evenly with 2, we're just left with a fraction of 5/2. Because we factored out a 2, we need to remember to multiply by a 2. Our b value is 5/2 divided by 2 squared. That gives us 5/4 squared, which is 25 over 16. Now we can go ahead and factor x minus 5/4 quantity squared equals negative 31 over 8. Now we can go ahead and solve. Divide both sides by 2. Negative 31 over 16. We'll square root both sides. So we'll have the square root of 31 over 4i, since it was negative 31. Don't forget our plus minus. And then we bring over our constant 5/4 plus or minus square root of 31 over 4i. And let's do one more. We move our constant, factor out the leading coefficient. Remember to multiply on the right. Our b value is 4, so we add 4 to both sides. X minus 2 squared equals 11. Now that completing the square is done, we can go ahead and solve. X minus 2 squared equals 11 over 3. Square root both sides, plus and minus, root 11 over 3. We'll rationalize. X minus 2 equals plus and minus square root of 33 over 3. And then we bring our constant over. Last thing we're going to talk about real quick is solving problems that are modeled by quadratic equations. And we'll take a look at our compound interest formula. Recall from our compound interest formula what the different parts all represent. A represents our final amount after all interest is earned. P stands for our principal. Remember, the principal is going to be our initial invested amount. R represents our rate. Any percent needs to be written as a decimal. If we solve for rate, the decimal can be converted back to a percent. T represents time in years. And N is our compounding frequency. Now, if we compound annually, then we can replace N with just 1, which allows us to simplify our equation for compound interest to what we have here. So what we can do now is we can look and see, given how much money I'm investing and how much money I want to end up with, we can now calculate the necessary rate that we would need to accomplish this. So here we have an investment of $2,000. That's our principal amount. And we want to end with a final amount of $2,420. We want to gain $420 in interest in a time frame of 2 years. That means we have to solve for the rate to figure out what rate we would need to accomplish this. So we can substitute those values into our formula. We want to end with $24,200. We're starting with $2,000 in principal. We don't know what our rate is, but we're investing for 2 years. This now becomes a quadratic equation which we can use our square root property in order to solve. We don't need to do completing the square because we already have the binomial squared. So we can go ahead and divide both sides by $2,000. That gives us 1.21 equals 1 plus r squared. Then what we can do is apply our square root property. Square root both sides, and we get that 1.1 equals, don't forget the plus and minus, 1 plus r. And then lastly, we will subtract 1 from both sides, giving us r equals negative 1 plus or minus 1.1. Since these are rational numbers, we can evaluate both negative 1 plus 1.1 versus negative 1 minus 1.1. This gives us a positive 0.1 or a negative 2.1. Since we can't invest at a negative rate, we can discard the answer that doesn't make sense in the context. And so we're left with a rate of 0.1, which in percentage notation would be a 10% interest rate. So in order to gain $420 in interest in 2 years off of $2,000, we would have to invest at an interest rate of 10%.